imaging with noise, and once it has been subjected to image processing, then it looks like this. Now look at here. If you give this X-ray image to a doctor, there is a chance that the doctor may not able to understand properly with this. Okay, and by subjecting this image to image enhancement, then you will be able to get these fine quality images where even the minor details are available for doctors to study, and accordingly a correct decision can be taken. That's what image after noise removal and enhancement. Friends, you might have heard that many a times you have taken CT scan or MRI or anything in some diagnostic center. The doctors will suggest that no, it is not of good quality. Again, that person will go to some other centers, again take similar scannings and again give it to the doctor. Right? Why we need to? Right? Why can't we use the technology for that? So definitely it is possible with this image processing. That's what is called a pre-processing, where we can remove noise, correcting artifacts and enhancing the contrast. So these are all a part of the medical imaging and also any such kind of machine learning techniques. And we can apply a linear filter, Kalman filter and spectral subtraction techniques and recurrent neural networks. I think some of you who have understood image processing and machine learning concepts, you can understand with this. And segmentation is another very interesting topic in any medical applications, particularly in research. So this is what is the images, and the doctor is interested in extracting this particular portion. That is what is called segmented ground truth images and predicted segmented images. This is the ground truth and this is the machine segmented images, and by comparing these two, we can understand how intelligent the machines are in segmenting the region of interest, which are used by the doctors to make a decision, and so followed by a particular prescription, etc. Right? And this is segmentation of region of interest for a COVID-19 by using some convolutional neural network. Now you can see the architecture of this convolutional neural network, right? So the images are given here. This is the architecture, and this produces finally the images, okay, where this neural network returns segmented regions of interest, and with this the doctors will be able to accurately identify whether the person is affected with the COVID-19 or what is the severity and what sort of treatment need to be given to that particular patient, and how severity it is, and what should be the medical attention required. All those decisions can be quickly made with the help of this, right? That's what the idea. And now look at here, brain tumor detection and segmentation. This is the original image and this is the segmented mask, and with this we will be able to quickly assess the issue. And this is what is called segmentation of region of interest with automatic segmentation of area of skin that contains a lesion. It can then be classified as a benign or a malignant, right? So again, look at here, this is the image, and the doctor is interested in a particular information here, okay, and based on that he can classify what type of skin issue with that particular person, and that is segmented and then analyzed and then quickly classify what sort of, whether it's a psoriasis or any other kind of skin related diseases, and accordingly the treatment can be given to the patient. So this is an example idea. And segmentation of region interest in some other CT scan images, look at here, this is the area and this is the area, right, which assists the doctors to quickly assess and accordingly do it. So there is another very interesting tool called level tracing, which are used by the doctors in a medical applications, which enable the doctors to take a different instances of an image, okay, and then they can make a wise decision. Level tracing allows you to auto-select a group of voxels based on the Hausen-Fill units of the selected voxel with adjustable tolerance. So of course the doctors can understand how they can use these tools to analyze the different orientations of the particular portion of the human body, and accordingly they can find out any issues or any ailments. So this improve the efficiency and accuracy of their analysis by doing so. This is what is called level tracing tool. You can explore if you are interested in it. You just type in a Google level tracing tool, you can get an animated video, but I could not put that animation here, but I just picked up some images. Another is magnetic lasso tool. Again, it is used for an effective and intelligent segmentation of a region of interest in CT scan images, right? So this is an example, and this is a cell nuclei segmentation. Okay, So you can have any such kind of blood cells, right? I think you might have seen where there is a glass plate where the bloods are smeared in it, and then they are identifying the different types of cells, and each of these cells can be analyzed and they can identify is there any issue with a particular patient regarding this and severity. All those things can be done. So the goal is to segment out the region containing the nuclei of various types of cells. This can assist in disease detection, cell counting, and various other medical use cases, particularly for cancer or oncology. For these kind of analysis are very, very important, which need to be taken with utmost importance. Abdominal multi-organ segmentation, look at here, how these are the various details which are collected through this segmentation information, and these are the particular cross-sectional views. With that, the doctors can make an intelligent decision. And abdomen organ detection, look at here. So with this, and the next few points related to this is the feature extraction, where the feature extraction is the very interesting part of any artificial intelligence tool, and particularly the machine learning, because if at all we want to learn something, then definitely the features are the attributes which characterize that particular image, whether it is a diseased or not diseased, whether it's a malignant or a benign. So any such kind of things are basically decided by the features which are extracted from an image or a video or an audio, whatever may be the data, or it could be a text as well, as I already mentioned, electronic health records. So from all these different types of data, we are extracting some set of features, and those features are used or analyzed to make a decision, and that's what is called the feature extraction. Now look at here, today with the advanced technology, the feature engineering can also be automated in a deep learning models. But in a traditional machine learning models, this feature extraction should be done by the researcher, right? So you have to extract the handcrafted features, then you can analyze, and then you can make a decision. But if at all you want to make it this automatic, then definitely we need a more computation power and more resources, and that's what is the deep architecture, which uses millions of records, millions of images, and millions of parameters need to be fine-tuned. So that's how the purpose of the feature extraction is to extract the key characteristics from medical images, and features include shape, texture, intensity, and spatial relationship, and crucial for diagnosing conditions and predicting outcomes, range from traditional descriptors to convolutional neural networks, and manual design versus automatic feature engineering. You can analyze and then identify the informative features, reduces the complexity, enhances accuracy, improves efficiency. That's a dimensional reduction. Not all features you have extracted from an image are used for analysis. Okay, so you can consider some important prominent features, and you can make the model more efficient and also more robust, and that's what is called dimensional reduction techniques. I think you might have heard about the principal component analysis, linear discriminant analysis. If not, I'm sure that once you get into the research, you will be exploring all those ideas, and the challenges are selecting the relevant features, avoiding the overfitting. So these are some of the technical things which we need to understand, and the integration means features fed into the classification for diagnosis and also the planning. And here is the visualization of a feature extraction model, and this is the given image, and these are the feature extracted, and then it is a semantic mapper, and finally semantic features, and this feature will be analyzed by the doctor to make a decision, or it can be made automatic by using intelligent AI tools. And similarly we have another set of images, and how this gist features are extracted from this and finally transformed to this form, and this will be studied by your intelligent algorithms or by the doctor in a semi-automatic environment, and that enables the doctors to make a decision or an AI tool to make a decision. And these are some of the very interesting things which we need to understand technically, and we can contribute more. Another thing is called image registration. I think you can understand how different images can be put together to extract a particular very interesting information, and based on that a decision can be made. Okay, so analysis, visualization, and then finally diagnosis, and then we can take a decision. So applications of medical image processing in healthcare, diagnosis, treatment planning, monitoring, and then particularly the research. And here is an example of diabetic retinopathy, right? Diabetic retinopathy for eye disease using deep learning. This is healthy, and this is disease. Now look at here, these parts which are hemomorphages, which are the causes for this diabetic retinopathy, right? So this is the fastest growing cause of blindness with nearly 451 million diabetic patients at risk worldwide. Look at the severity of this. If ignored, then the person will become blind lifetime. So a precaution can be taken at the early stage, and it can be diagnosed and treatment can be given so that it can be addressed well in advance and the early stage so that the person will be safe. So here the experts have explored the possibility of the deep learning model for analyzing this, and the Google has developed a deep learning algorithm capable of interpreting signs of diabetic retinopathy in retinal photographs. They created a data set of 128,000 images, and each labeled by 37 ophthalmologists from a panel of 54 ophthalmologists. Now look at here, this is what is the training required. It's not so easy to design any intelligent systems, okay? A lot of images, lot of resources, and lot of infrastructures are also needed, and with this they have analyzed this one, and of course I can just show you the final results. The F-score combined sensitivity and specificity of the algorithm was 0.95, which is slightly better than the median F-score of the 8 board certified ophthalmologists measured at 0.91. Look at here, the experts themselves have analyzed these images and they have come to the accuracy of 0.91, and here the intelligent algorithms has produced 0.95, almost 5% more accuracy than the experts, and that shows the promising promise that the AI tools can definitely help the doctors to make intelligent decision, and also they can reduce the error. So then what does this study entail? Okay, AI can now offer an automated system for diabetic retinopathy detection with a high accuracy and near instantaneous reporting of results, consistency of interpretation. The algorithm will make the same predictions on the same image every time, and this is what is called consistency. But many times what happens today, we can't trust the doctors many times, right? Because one doctor says that yes, a person has this problem, and another doctor says that no, it's a different problem. So the consistency, right, issue. So how can we ensure the consistency? So definitely these intelligent tools will make doctors to always give a consistent report on whatever they are going to analyze. Okay, so today without second opinion we cannot take any decision at all, right? But here with the help of these technologies we can promise that yes, the decision taken by the doctor is robust. Okay, so that's what, and of course there are some, I think we have next session, right, at 12? At 12. So just another 2 minutes, I will just conclude. Right, because I thought that the session will start at 9:30, but it went on 10:30. So I could include more details to cover. Anyhow, it's no issue. This material will be shared with you. You can study it, understand, and of course you can make a decision. So there are some data sets in healthcare, INVEST data set, okay, and then BCDR data sets for breast cancer digital repository, okay, and also we have different types of data set I have mentioned here. In case if you are interested to work on any of these, you can find the data sets which are available as a benchmark data set, and you can use those data sets and you can work on it. Okay, see MS Brain, Riga, and many things are there, retinal and MRI images of brain for tasks like segmentation, registration, and many things as such. I have listed out, you please go through it. And here are some of the works related to machine learning and deep learning techniques for medical imaging. Okay, we have mentioned the technique, parameters, identify diseases, and performance parameters, and all these comparisons will help you to understand the state of the art technology and what is the scope to work further. Okay, so I have just mentioned some of the techniques and challenges and also the conclusion, right? Of course, the transfer learning was used to cope up with the image variations, and also multiple instance learning and weighted transfer learning used to overcome the weakly labeled data and improve the accuracy of the disease classification for better medical results respectively. So these are the percentage of modalities used in the medical imaging. This is also very good statistics for you to understand what is the state of the current healthcare and what are the different modalities which are used for exploring and further scope to explore all these modalities. So here we have mentioned MRI, X-ray, CT scan. See, CT scan, I think MRI, X-ray is 45%, CT scan is 30%, mammogram is 10%, ECG is 5%, and eye scan 2 is 10%. And these statistics will help you to understand the importance of these medical imaging modalities, the scope, and further research and etc. The tools used in medical analysis, TensorFlow, NumPy, MATLAB, and R, you can understand that 38% for MATLAB, 12% for TensorFlow, NumPy for 37%, and then R is 13%. And similarly, percentage of various techniques used in the primary studies, you can see the different techniques like random forest, transfer learning, SVM, and ANN, and many things, decision tree, okay, BCA, LDA. So these are some of the interesting statistics for you to understand more about the research in particularly healthcare and also AI. And statistical analysis of ML and DL techniques for medical diagnosis. So I think this requires much more understanding and time to look at it. So you please go through it. Okay, with this, a summary and a conclusion. This presentation attempts to provide an overview of various ML and DL approaches for disease diagnosis along with the classification, image modalities, tools, techniques, data sets, and challenges in the medical domain. MRI and X-ray scans are the most commonly used modalities for the disease diagnosis. Among all the tools and techniques studied, MATLAB and SVM dominated respectively according to this study, right? Maybe recently you can even find other tools and techniques. A series of experiments using MRI dataset has provided a comparative analysis of machine learning and deep learning models where CNN has achieved 97.6% with a random forest classifier 96.93 have outperformed other algorithms. And due to the superior performance, DL approaches have recently become quite popular among the researchers, and this review will assist healthcare community, physicians and clinicians and medical practitioners to choose an appropriate ML and DL techniques for the diagnosis of disease with reduced time and less, high accuracy. So with this, now I conclude by saying these important statements by eminent personalities. Machine learning can't get something from nothing. What it does is get more from less. And that's what is stated by Pedro Domingo, University of Washington. And research is to see what everybody else has seen and to think what nobody else has thought. Dr. Albrecht, okay? So these are very interesting and very powerful statements by the great people. And these are the motivating factors for young researchers and the technocrats to walk in this direction, and you can contribute to the field of healthcare through machine learning, image processing, computer vision, and also put together artificial intelligence. Okay, so with this, here are some references for you. Okay, you can please go through it. And with this, I thank you all for your patience, listening, and cooperation. So, dear friends, normally whatever I have covered in 1.5 hours is a stuff for one semester or more than one semester, strictly speaking. And those people who are into this particular domain can understand the intensity and the depth of these things. But here the intentions or the objective is not to go from the scratch because it's an FDP. Okay, just to give you an overview where you can decide what is your interest, what is your domain, and accordingly you can plan and you can proceed further in that particular domain. And each person's contribution will be pooled together, integrated together, and that creates a wonderful AI tool, right? It is not that one person can design all those things. It is a teamwork. It's a collaborative work. So everybody contributing a little bit, and that will be put together, and that builds an intelligent model which will be used in the future for serving the society. That's what is the main idea. So with this idea, my intention with this lecture was to give you an overall idea of how this AI and particularly machine learning and deep learning and medical image processing will contribute to the healthcare. So a lot of things are there to explore. You please go ahead maybe in the coming sessions, even you can explain and experience the practical classes, and also you will get a practical knowledge about how exactly these techniques can be realized and implemented. Okay, so that will give you a wonderful experience. Right, with this, once again, I thank the organizers and principal and the staff members and each one of you for providing me this opportunity to share my little knowledge with you all today. And thank you very much for your cooperation and patience listening. I wish you all the best in the coming days in this faculty development program. Thank you very much. Thank you.
Good afternoon, everyone. I, Devi, Assistant Professor of BCA Department, take this opportunity to extend our sincere thanks to our esteemed resource person, Dr. H.S. Nagendra Swami, for gracing us with his presence and delivering an enlightening session on the scope of AI in healthcare. Sir, your vast experience, clarity of thought, and deep insights into the subject have truly inspired us. The way you connected cutting-edge technology with real-world healthcare challenges was both informative and thought-provoking. We are indeed privileged to have had the opportunity to learn from you today. On behalf of all present here, I express our heartfelt gratitude for your valuable time and contribution. Thank you once again, sir. Good afternoon, everyone. The restroom is to boys. It's in the ground floor and second floor. The first floor